Hello, welcome back to Daily Dose of Frost Language. Today we are going to discuss something very important and very special, which is called generics. Now, let me give you a real life scenario here. Let's say you have a restaurant that only sells one kind of food. So naturally, when you call them to send some food to you, let's say they sell jollof rice, which is a very common type of cooked rice here in Nigeria. Whenever you call them, you're 100% sure that they're going to send you jollof rice. So you no longer have to worry about any other thing. Now, let's say one day they start selling more than just jollof rice. Then it automatically means that whenever you call them to send you food, then you must tell them the type of food to send you. So this is what generic looks like. So for example, here we have this function that we call find smallest that accepts a slice of values. Here, a slice of I32 values, okay, and then returns the smallest number inside that value. So all it does is it loops through those values and then continue to check which one is the smallest and store the smallest here and then return it later on. Now if you look closely, you notice what the problem is with this function. It can only work with integer types of I32. You can't use it with I, U8 or whatever. Okay, for example here, as an example, let's say I want to use it on I32 values. You see that it's going to work. Let's try it out. Now we have this variable that we call values, and then we can find the smallest value here by saying we call find smallest and then we pass the values. Now we can then print that to the terminal. Then when we run that code, we get that the smallest value is 1. Now, just for good measures, let me switch it up a little bit and then run it again. We get smallest equal to 3, and that is the smallest number here. So clearly it works for I32 values. Now, this is just like this restaurant that serves only one type of food. Now what if this restaurant upgrades, like we upgrade this function to also calculate other types of integers? Of course that will make sense, because if you don't do that and you want to calculate a vector with values of type floating point types like F64 also, we won't be able to use this function for it, right? In fact, I can show you right now. If we have values and we have values too, okay, which will be a vector that will hold integer values. Let's just say dot zeros here. Now if you decide to find the smallest values for this one, it's not even going to work. If we run that code, the code will panic. You see, the code could not compile, and if you look here, it will say expected slice of I32 but found vector of a float. And by the way, let me clear this up. Remember that when we call this function, we have a vector here, and you might be wondering, now in case you're wondering how this function accepts a slice of values of type I32, but clearly here when we call the function, we are passing values which is of type vector, right? So we are calling this function with vector while it accepts slice of values. That is actually true, and it works in fact, simply because the values are stored the same way in the database. So a slice of value, okay, is similar to a vector, because a vector is also a slice of value, okay, because they look quite similar and are stored the same stored in a similar way in the memory. So that is why you can be able to use it here. So our endeavor is to make sure that this function, which is like the restaurant in our case, will be able to calculate both floating point values and other values and all that. So what we can do is to duplicate this and modify it a little bit using generics. Okay, all we have to do, because the major difference here is that it's accepting just one type. That is the only difference. So let's make it accept all kinds of types, and not even all kinds of types, but the types we want. So not only are we going to call it to perform some value, some calculations, we will also tell this function the type is going to accept, and the type is going to work with, and the type is going to return. Now, in order to do that, the first thing we have to do is to use this angle brackets and then provide the type we want. So now we just want to provide a placeholder. So let's just call it T. This is just like a convention. Whenever you are doing something like this, we usually call it T because it signifies type. So, but you can call it anything you want. You can even use a word here, but let's just call it T for this purpose. Okay, and then once we've provided T here, then we can now use it inside here. If we don't provide it here, we won't be able to use this type here. And then here we also declare that the parameter will be of type a slice of those type that you provided. Okay, and automatically it will also return that type as well because you are switching things out. Okay, and let's just rename this one and leave it there for now. Now automatically, if we have another value here, value 2, which is made up of floating point types. So now all of a sudden, by using generics, which is providing the type we want, we are now able to tell this restaurant that was selling one type of food before that is now selling a lot of foods. We are able to tell it the particular food we need. And in this case, we are able to say, calculate these integers, or find the values, find the smallest value between these floating point values. So we are no longer restricted to just one types of value. But there's another problem. Now, because we are just providing the type here, Rust doesn't know exactly which type we need here when this function is defined. And that is because we just made up this type ourselves, T. Okay, we will only provide what it's going to be when we call it. Now, if you hover over this, you can see what Rust is saying. It is a binary operator, this, which is this less than sign, cannot be applied to type a reference of T. So it doesn't know what T is at this point. So, but the problem is that we are trying to perform a logical operation on these two values that Rust doesn't know what they are. Doesn't know if they are strings or if they are going to be integers or what. So, but we have a hint. In fact, let's run the code and see what Rust will say. Now, of course, the code could not compile, but if we move up here, it will still say the same thing. But if you move down a little bit, it will say help right here. This is a hint it's given. It says consider restricting type parameter T. So what we can do here is to give Rust a hint of what T is. So to perform this logical operation on these two values, okay, for integers, Rust would like to work with some values that can be ordered, that are orderable. And Rust has this thread in the standard library that is called partial order. Okay, and we'll use it here. So once we've added a type constraint to T right here, we are now technically telling Rust that the value or the type T will implement this partial order, which means it can be orderable. And that will signal to Rust that this operation can be done without errors. And that is why the error is gone now. And we can now use it. So we'll still talk about threads and how to use them with generics in this case. We'll still talk about that later on. But if we run that code now, we are now able to get the value 3 in this case. And we can also call it with float, and it's still going to work. So this is the idea of generics, being able to achieve more, work with many types in one function or even in structs without being limited to a particular type. Now in the next video, we'll take a look at how to use generics in structs and in other data types in Rust. So I hope now you have a hint of how generics works in Rust. I hope you now have an idea of how generics works in Rust. Now, before I go, pay attention to this again. In other languages, usually when you call a function like this, or a struct where you have generics, you usually have to provide the type of that generic. Okay, for example, we are calling this function with this type T. In other languages, you might come down here and then provide that T maybe inside a curly brace. We provide that T is going to be of type i32. Okay. In Rust, you don't need to do that. Rust will infer the type for you. So for example, here that we call find smallest and we pass values. Rust will look at values and find out that it's a vector of integers. Then it will automatically infer that in that case, that T will be of type i32. The same thing for float. Rust will infer that T will be float at that point. So you don't need to provide that type here. So in case you're wondering. Okay, so that's it guys for this video. Make sure you subscribe and like the video. And in the next video, we will take a look at how to use these generics in structs and in other data types in Rust.